talk about note card 7. We're going to actually build note card 7 together, and we're going to get everything for note card 7 basically from the unit circle. Let's talk about this and let's try to break it down, and let me make it as simple and in as quick a way as I possibly can. Okay, first thing is, remember that each terminal side of these angles here are all radii, or each one is a radius of the circle, and they are of length 1. Okay, every one of them is length 1. And right now I'm just going to look at this first triangle, which is a 30, 60, 90, this first one here, which is dealing with angle 30 degrees here. Okay, we know from what we've learned by building our paper plate unit circles that we came up with all of these ordered pairs. Okay, and so this ordered pair here, where each radius meets the outer edge of the circle, creates an x and y value. Okay, and this xy value here we found to be √3/2, 1/2. So this is my x value and this is my y value. So the x value here is √3/2 and the y value is 1/2. Okay, so this is the y. And this is the x value. If you go back to note card 4, you will find the following ratios. You have that sine theta is equal to y/r. You have cosine theta is equal to x/r.
Students and teachers, please pardon this interruption.
And then we also have, I'll put over here somewhere, that tangent theta is equal to y/x. Okay, well, let's take a look at this. If sine theta is equal to y/r, y/r, and if r is 1, then sine theta is equal to y/1, or just y. Likewise with cosine. Cosine is equal to x/r, so x/r, and again x is just 1, I'm sorry, r is 1, so x/1 is x, so it's going to be x/1, or simply x. So what does that tell us so far? Well, what it tells us is that for all of these ordered pairs around the circle, it tells us that the y value of each ordered pair is the sine of that angle. So the sine of 30 degrees, or pi/6, and remember when I say 30 degrees or pi/6, I'm referring to the angle measurement. 30 is in degrees, pi/6 is in radians. I will mostly be referring to pi/6, the radian form. So the sine of pi/6 is half. The sine of pi/4 is √2/2. The sine of pi/6, or 3, I'm sorry, is √3/2, and so on around the circle. The sine of that particular angle is the y value of the ordered pair. The cosine of that particular angle is the x value of the ordered pair. So cosine of pi/6 is √3/2. Cosine of pi/4 is √2/2. Cosine of pi/3 is 1/2. And again, all the way around the table. Okay? So what I know so far is that when I'm looking at my unit circle, that every xy value, the x value is cosine theta, and the y value is sine theta. Okay, so if the x value is cosine theta and the y value is sine theta, when I'm looking for tangent theta, that's y/x, or sine theta over cosine theta. And this is where we have to do some calculations. Let me give myself a little room. Okay, so we know that tangent is equal to sine theta over cosine theta. Let's see if we can find the tangent of pi over 6. Well, we know that that's going to be equal to sine theta over cosine theta. Well, what's sine of pi over 6? Sine of pi over 6 is 1/2 divided by cosine of pi over 6 is root 3 over 2. So if I can simplify this, I have the tangent of pi over 6. What I probably want to do first is, instead of looking at my division like this, with the big fraction bar in the middle, I might want to change it to a division problem that maybe looks like this: 1/2 divided by root 3 over 2. Because this is the same thing. This says 1/2 divided by root 3 over 2. And then I just use keep, switch, flip. Remember, when you're dividing fractions, you do keep, switch, flip. Very important here. You keep the first fraction. You switch the sign from division to multiplication. And you flip the last fraction. Then it's top times top, bottom times bottom. So 1 times 2 is 2. 2 times root 3 is 2 root 3. We can't have radicals on bottom, so we need to multiply that by root 3 over root 3. 2 times root 3 is 2 root 3. Then we should know by now that root 3 times root 3 is 3 times this 2 out here, because 2 is being multiplied by this root 3. So I get 2 times root 3 is, again, 2 root 3, and then 2 times 3 is 6. Now, I'm not finished. I can simplify this, but really quick, going back to this step, 2 times root 3 is 2 root 3. Then root 3 times root 3 is 3. Then it's times this 2 out here. And 2 times 3 is 6. The 2 over 6 reduces to 1/3, so this is going to be root 3 over 3. So we've learned that the tangent of pi over 6 is root 3 over 3. And I can use this information to fill in my trig value chart, because now I have given you all the tools that you need to find the sine and the cosine of every angle around the circle. You can find the tangent for every angle around the circle by dividing that sine by the cosine. And then the final functions, cosecant is just the reciprocal of sine, secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. And I can even make it a little bit easier than that. Let's take a look at the blank trig value chart. Okay, the first thing that I'm going to do is I'm going to start at the top, and I'm going to, this first column says degrees, so I'm going to have 0 degrees, then I have 30 degrees, and I'm just following my unit circle around. Then I have 45 degrees, then I have 60 degrees, then I have 90 degrees. This is my first quadrant. I'm working in quadrant 1 right now. Okay, so again, following my unit circle, I can fill in the radians. Well, 0 degrees is 0 radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians, and 90 degrees is pi over 2 radians. Okay, this one right here is going to be a special case. We'll save this one for, I'm talking about it later. I'm not even going to fill out all of this. I'm going to show you how to do 1 or 2 lines and how it applies to the rest of the quadrants. Let's take a look at 30 degrees. The sine of 30 degrees, since it is the y value of the ordered pair that corresponds to that 30 degree angle, is 1/2. The cosine of 30 degrees is the x value of that ordered pair, so that's √3/2. Again, I'm looking at my unit circle. And we just found out that the tangent of 30 degrees was √3/3. And now I can find cosecant, because cosecant is the reciprocal of sine, so that's going to be 2/1, which is 2. Secant is the reciprocal of cosine, so that's going to be 2/√3, which I can't have radicals on bottom, and when I simplify that by multiplying by √3/√3, I get 2√3/3. And then cotangent is the reciprocal of √3/3, which is 3/√3. And when I simplify this, it just becomes √3. And I'll show you quickly how. Times √3/3, which is 3√3/3, and those 3's cancel, leaving me with √3 here. Now, that's how you will find each row, again, in the first quadrant. Very simple. Sine is the y value of the ordered pair. Cosine is the x value of the ordered pair. Cosine theta, comma sine theta. X, y. Okay, I can find tangent by dividing sine theta by cosine theta. Sine theta over cosine theta. Tangent theta is equal to sine theta over cosine theta. Then these following 3 ratios or functions are the reciprocals of the first 3. That's how I can fill out the entire first quadrant. I can tell you that there may be some that are undefined. If you get a 0 on bottom of your fraction, that's undefined. Okay? Now, let's see how this relates to the rest of the quadrants. Okay, I continue on with 120 degrees, 135 degrees, 150 degrees, 180 degrees. This is quadrant 2. Okay, and I'll let you fill in the following corresponding values of the radians for each one of those. They're right there on your unit circle. So let's look at which family goes with 30 degrees. Well, 30 degrees goes with 150 degrees. Those colors of the angles should be corresponding on your paper plate that we made the unit circle on. So these two correspond, so watch how this works. All I'm going to do is copy down every value into the blank on 150. Sine is 1/2. The cosine is √3/2. The tangent is √3/3. The cosecant is 2. The secant is 2√3/3. And cotangent is √3. But you have to keep something in mind. The signs, S-I-G-N, change depending on which quadrant you're in. Remember, all students take calculus. In the first quadrant, they're all positive. That's why right here, there are no negative values here. They're all positive. In the second quadrant, only sine and its reciprocal cosecant is positive. That means that everything else is negative. Cosine's negative, tangent's negative, secant's negative, and cotangent's negative. And that's how I will fill in these values all the way down my chart. The hardest part of this is quadrant 1. If I can fill out quadrant 1, then all I do is put the absolute value from each blank will go into the corresponding box for that family. Okay? For 45, that's going to go, my 45s are going to go with my 135s. And so on. You know your angle families. And then, once you get those absolute values put on there, do like I did and use all students take calculus and change the signs to negative if need be. And you should be able to do this, and we shouldn't have any problems out of it. I think I've covered everything. I don't think there's really anything else to talk about. I will remind you that when you're finding these values, if you end up with any kind of a fraction, such as 1 over 0, then you're going to have something that's going to be undefined. Let's use right here. Let's look at 90 degrees, for example. 90 degrees, what ordered pair is associated with 90 degrees? That's going to be 0, 1. Okay? That tells me right away that the sine of 90 degrees is going to be 1 because it's the y value. And the cosine of 90 degrees is going to be 0 because that's the x value of the ordered pair. Okay? And the tangent is going to be sine divided by cosine, which is going to be 1 divided by 0, which is undefined. And you may end up with some things like that. There's not going to be too many of them. You're just going to have one every now and then. Just pay attention to that, and you should be good to go.